Hello dear students, welcome to my channel Conceptual Physical Chemistry. Today I am going to discuss about a very important topic of physical chemistry, that is photochemistry. Myself, Dr. Sharayu Thorat, Associate Professor, Shri Shivaji College of Arts, Commerce and Science, Akola. We are going to discuss in this important topic the following points: introduction and characteristics of photochemical reactions, difference between photochemical and thermal reactions, laws of photochemistry, and some important relations. In the introduction, we can discuss the importance of this topic, that is photochemistry. Photochemistry can be said to be the subdiscipline of chemistry, and it is the study of chemical reactions that proceed with the absorption of light by atoms or molecules. Everyday examples include photosynthesis, then the degradation of plastics, and the formation of vitamin D with sunlight. Light is said to be a source of energy, that is electromagnetic radiation. So here we can understand that we require light for photochemical reactions. So we can say that photochemistry is the study of chemical reactions resulting from the exposure of light radiations. Light supplies the required energy for the photochemical reactions. So the visible and ultraviolet radiations in between the wavelength range 2000 to 8000 angstrom unit are mainly used in carrying out photochemical reactions. Whereas thermochemical reactions or dark reactions are brought about by molecular collisions. These reactions are spontaneous and they are accompanied by a decrease in free energy, but certain photochemical reactions are accompanied by an increase in free energy. Now, what are the common light sources of photochemical reaction? For visible and infrared light radiations, we can use bright incandescent lamps or high intensity flash lamps. For monochromatic light radiations, we can use laser diodes or ultraviolet LEDs. So we can say that all photochemical reactions take place in two steps. In the first step, the reacting molecules are activated by absorption of light. In the second step, the activated molecules undergo a photochemical change. For example, in the combination of hydrogen and chlorine, the first step is chlorine molecule absorbs quantum of radiation, that is H nu, to form activated chlorine atoms. These activated chlorine atoms then undergoes chemical reaction. So it is evident from the above reaction that the second step can occur in absence of light. Now, characteristics of photochemical reaction, we can say that photochemical reactions take place by absorption of light. When a light composing number of colors is used, the photochemical reaction may not be initiated by all colors. The free energy change, that is del G, of a photochemical reaction may be either negative or positive. We can depict the thermal and photochemical reaction as below. If we consider A as a reactant giving rise to the product B, then that is the thermal reaction. But in case of photochemical reaction, the reactant A absorbs quantum of radiation, that is H nu, to form the activated species A star, which then gives rise to the product B. Now let us discuss the differences between photochemical and thermal reactions. In photochemical reactions, these involve the absorption of light. In thermochemical reactions, these involve either absorption or evolution of heat. Photochemical reactions take place in presence of light, whereas thermochemical reactions take place in dark or in presence of light. Photochemical reactions are independent of temperature, whereas thermochemical reactions are dependent on temperature. Rate of the reaction is dependent on the intensity of the light absorbed in case of photochemical reaction, but in case of thermochemical reactions, rate of reaction is not affected by the intensity of light. Then in photochemical reactions, the free energy change is negative or positive, whereas in thermochemical reactions, the free energy change is always negative. Now let us discuss the laws of photochemistry. The first law, that is the Grotthuss-Draper's law, or it is also called as the principle of photochemical activation. Grotthuss-Draper's law states that only the light which is absorbed by a substance can bring about a photochemical change. However, the absorbed radiation does not necessarily cause a chemical reaction. When the conditions are not favorable for the molecules to react, the light energy may be re-emitted as heat or light, or it remains unused. The second law of photochemistry is also called as the Stark-Einstein's law of photochemical equivalence, or the principle of quantum activation. Now, according to the second law, it states that in a primary photochemical process, that is the first step, each molecule is activated by the absorption of one quantum of radiation, or we can say one photon. But here also, when a molecule absorbs a photon, it is not necessary that only one molecule should react. The absorption of one photon by a molecule is only the first step, resulting in the formation of an activated molecule. This further may or may not react, or may cause the reaction of many molecules through a chain mechanism. Now let us discuss some important relations. When we say photons, that is equivalent to quanta. One molecule absorbs one photon. 1 mole of a substance contains 6.023 into 10 to the power of 23, that is Avogadro's number. That is equivalent to 1 mole of quanta, or 6.023 into 10 to the power of 23 quanta of light, or it is also called as 1 Einstein. So when we say that molecules absorb 1 Einstein, then that is equivalent to the energy, that is N into H into nu, or it is also equal to N into H into C divided by lambda. As we know, nu, that is the frequency, is equal to C divided by lambda. Here lambda is the wavelength of the light. So if we have to calculate the energy of photon and an Einstein, then we can calculate by the equation E is equal to H into nu, or E is equal to H into C divided by lambda. What is H here? H is the Planck constant, whose value is 6.625 into 10 to the power of minus 34 joules second. C is the velocity of light in SI system, 3.0 into 10 to the power of 8 meter per second, and lambda is the wavelength of light. The energy of an Einstein, if we have to calculate that, then that is equivalent to Avogadro's number, that is N of photons. So the energy of an Einstein can be calculated by the formula E is equal to N into H into C divided by lambda. On substituting the values in the above equation, the value of energy comes out to be 0.1196 divided by lambda joules per mole in SI units. Now what is N here? N is the Avogadro's number. Then H is the Planck constant. In SI system, the value of Planck constant is 6.626 into 10 to the power of minus 34. C is the velocity of light, whose value in SI system is 3 into 10 to the power of 8 meter per second. Now if you have to calculate the value of energy in CGS unit, then substitute the value velocity of light, that is 3 into 10 to the power of 10 centimeter per second. H, the Planck constant, whose value in CGS system is 6.625 into 10 to the power of minus 27 ergs per second. So on substituting these values, the value you get in CGS system, that is 1.196 into 10 to the power of 8 divided by the value of wavelength, that is lambda, in angstrom unit. So the value of energy you get in ergs per mole. Now if you have to calculate the value of energy in calories per mole, then you will have to use the relation 1 calories is equal to 4.184 into 10 to the power of 7 ergs. If you substitute the values of all these, then the value of energy in calories per mole comes out to be 2.859 divided by lambda, that is calories per mole. This was all for today. Thank you and have a great day.